Hey guys, it's Mrs. Wheelie, and we are on week 2 of our distance learning. So if you went to school today and picked up your packet, then you might have already been working on things. But for this week for math, day 1 is arrays. We're going to be reviewing our multiplication and division skills this week. So your worksheet for today was arrays, using rows and columns to help us make our multiplication sentences. So we're going to go ahead and look at A. And when I look at A, and you can follow my pointer on the screen, I see that it has 1, 2 rows. So I would write down the number 2 next to the word rows. And then as I build my multiplication sentence, I'm going to do rows multiplied by columns is going to give me my product. So I'm going to do it like this on my whiteboard. All right, so I have 2 rows and I have columns. They go up and down because columns, the way I always remember it is columns are like those beams that hold up a building. Sometimes you see them in really, really big houses or government buildings, and they go up and down. And so I'm going to count my columns, and I have 1, 2, and 3. So my multiplication sentence is 2 multiplied by 3. Now, some of us, we've been practicing our multiplication for a while now, and we might just have it memorized. It might be a known fact for us. Others of us might still struggle. And so using arrays is an easy way for us to organize the factors to find the product. And don't forget, your product is your answer to a multiplication problem. So if we don't just have it as a known fact, I can count them up. I can count up by ones and just touch each one and say 1, 2, 3, 4, 5, 6. Or I can count by twos and say 2, 4, 6. And so I know that 2 multiplied by 3 equals 6. And so that's what you should have put in the bottom multiplication sentence that's down here. All right, so I'm going to just quickly review with you what you should have done for each of them now that I talked you through a strategy for solving. So B, I'm going to count my rows. I have 1, 2, 3, 4. I would record 4 multiplied by, and now columns, and I see that I have 2. And I know that fact, and 4 multiplied by 2 equals 8. All right, C. Ooh, this one's getting bigger. But I'm going to use the same strategy. I'm going to count my rows. I'm going to count my columns. And then if I need to count them all up, I can count by ones, or I can skip count by however many are in a row, or skip count by however many are in a column. Either way works. So I'm going to count my rows first. And I have 1, 2, 3, 4, 5, 6, 7 rows. 7 multiplied by, and now I'm going to count my columns. 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Now, another strategy you can use if you don't want to sit and count by ones. If you sit and you go, ooh, I'm not the best at counting by sevens either, you could do repeated addition. That could help you too. So I could do 8 7 times, or I could do 7 8 times. I can choose whichever one is easiest for me. I think it's a lot easier for me to count by 8. So I'm going to do 7 8s for this. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put an addition symbol between each of my 8s, because I'm going to do my repeated addition. 1, 2, 3, 4, 5, 6, 7. Oops, I accidentally drew an extra one. That's why it's always smart to double check my work. So now I just took it and I made it a repeated addition sentence. And now I'm going to just start adding it up, because that's another strategy. When I get to these larger numbers and I haven't memorized it yet, I know that in my classroom that not everyone has gotten to their 7s yet. And so we might not have it memorized. And so we might need to use another strategy. Also this week in your distance learning packet, I put a strategy sheet for multiplication, for division, and also addition and subtraction are in there. There is a sheet that you might not need to use at all, but it might be helpful for an older sibling. That's multiplication strategies with 2-digit numbers, but that would be something that would be helpful maybe for an older sibling. We might not need it this week with what we're learning. So now that I have that, I'm going to just go through and add all these up. And I know my doubles fact, and I know 8 plus 8 is 16. I'm going to go through and do all of that. Bring my addition sentence down. Bring down the remaining 8 that I have. That's where I'm at now. I'm going to keep going. And I know that 16 and 16 is 32 plus 16 plus 8. And I'm going to just keep on going until I solved it all. So now I have 32 plus 16 plus 8. Where are you at? Did you do this? And so I have 32 plus 16, and I know that 2 plus 6 is 8. I'm going to add my 1s first, and then I'm going to add my 10s, and 3 plus 1 is 4 for my 10s. So now I'm at 48 plus 8. And I can add my 1s, and I could say that 8 plus 8 is 16, and I still have 4 10s left, which is 40. So I can say 16 plus 40 equals 56. That's 7 times 8 equals 56. And if this is the work that you have to do to get you to the answer, then this is what you do. Grab an extra piece of paper and use your strategies. Okay? All right. So C, you should have said 7 times 8 equals 56. D, count those rows. 1, 2, 3, 4. So I'm going to say 4 multiplied by my columns, which is 1, 2, 3, 4, 5, 6. Ooh, I know my 4s, and 4 times 6 is 24. So for D, I got 4 times 6 equals 24. E. And if you see here, I'm going to just label so you can always check as I go. Rows first. Here we go. 1, 2, 3, 4, 5. Now my columns. 1, 2, 3, 4, 5. Ooh, I like 5s. They're pretty easy because I can also skip count by 5. So I'm going to just hold 5 up, and I'm going to say 5, 10, 15, 20, 25. That's another way to double check yourself. If you know how to skip count by the multiple, you can do it that way too. So for E, 5 times 5 equals 25. All right, F. Count those rows first. Here we go. I gotta look real close. That's getting smaller and smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 rows multiplied by 1, 2, 3, 4, 5, 6. 9 times 6 equals, with 9s, this is what I like to do. I like to think of the 10 and then subtract a group. So I know that 10 times 6 equals 60, but that was one too many groups of 6. So if I say 60 subtract 6, and I take that extra group away to make it the 9 groups that I need, if I say 60 subtract 6, I can count backwards. 59, 58, 57, 56, 55, 54. So 9 times 6 equals 54. And that's another strategy that you can use to help you out. All right. So now I'm going to go to G. Oh my goodness, those squares are so small. That means the number's going to be so big. Here we go. I better count rows first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow. 11 rows multiplied by, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my goodness. 11 multiplied by 12. That one's a really big number. Now, some of us would be really tempted right now to just start counting by ones because that is something we know how to do. Others of us might sit and want to start doing repeated addition, doing 12 11s. That's a lot to do. So parts of me stops and thinks, is there another way that I could do this that's just a little bit more efficient? Distributive property. I can choose to break one of these numbers up and then multiply how I broke that number up by the factor that I left alone, and then take the two products and add them together. I can use distributive property. So here I go. I'm going to break what do I want to break up? I'm going to break up the 12. And I'm going to break up the 12 into 10 and 2 because I actually kind of think it's easy to multiply by 10. And so I'm going to say 11 multiplied by 10 equals, and then I'm going to say 11 multiplied by 2 equals. And then what I'm going to end up doing is I'm going to take these two products. So what you can see is I took the 12 and I split it into 10 and 2. And then I'm going to take those two factors that I created from my one factor, and I'm going to share it, so distribute it, with the 11, the factor I didn't touch. And I'm going to say 11 times 10, get my product. 11 times 2, get my product. Take those two products and add them together, and then I get my overall product for my original multiplication sentence. This is a way to break up something that has larger numbers into easier, smaller chunks. It's a lot more efficient than sitting and counting by ones. But there is nothing wrong with counting by ones if that's what helps you out and gets you to the answer, honestly, because it's already drawn. All you have to do is count. All right, so here I go. I am going to skip count by 10 11 times because it's easier to skip count by 10. So I'm going to hold up 10 fingers because I got them. And then I'm going to do one more than I have. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So 11 times 10 is 110. Now I'm going to do 11 times 2. And I know identity property, and I'm going to use my knowledge of identity property. Anything multiplied by 1 is itself. So I'm going to kind of think that, but like in double, because I have 11. So I have two ones but one's in the tens place and one's in the ones place. So its value is different, but I can use that idea of multiplied by 1 to help me here. I know that 2 multiplied by 1 is 2, and that's going to be in my ones place. And I know that 2 multiplied by 10 is 20, and that's going to go in my tens place. So I'm going to say 110 plus 22 equals 0 plus 2 is 2, 1 plus 2 is 3, and 132. That's how I did that one. Even though it was really, really big numbers, I just used a different strategy to break it apart and make it more efficient. So for G, 11 times 12 equals 132. All right, H. Whew, those boxes are bigger, meaning my number is smaller. I won't have to squint either. Here we go. 1, 2, 3, 4. I counted my rows first, and I have 4 rows multiplied by my columns. 1, 2, 3, 4. Oh, I know this one. 4 times 4 is 16. H, you should have said 4 times 4 equals 16. All right, guys. If I didn't use a strategy that you prefer or you like, it's okay. You and I can think different. Go to the strategies sheet I did send home in the distance learning packet and look at some of those ideas. And use them to help you if you need some assistance. All right, I'll see you guys tomorrow for day 2 of week 2.